Hi everyone, I'm going to run through the EPMATH126 revision paper for the mid-semester exam. Note in the instructions is the same as what we'll have in the actual mid-semester. All questions should be attempted, there's no optional ones, all answers have to be written on this paper, yep. Show all necessary working. Any question worth more than 1 mark requires working, that's a definite. If it's a 2-mark question and you write answer only, you get 0. So give us some working to show that you've understood it. Calculators are not allowed, and of course we have a resource sheet allowed, handwritten, A4, double-sided. Starting off with root 7 is a real number. The only numbers that aren't real are square roots of negatives. Like square root of -4 is asking the question, what number times by itself to give a negative? And how can that have an answer? 2 positives will multiply to give a negative. Will multiply to give a positive, sorry. 2 negatives will also multiply to give a positive. So how can any number multiply by itself to give a negative? So the only number that isn't real will be the square root of negative, and this is not it. Root 7 exists. It's a real number. So yes, it's real. Pi is a rational number. Pi is one of the few irrational numbers we deal with. Pi is 3.14 and it goes on and on and on without a fixed repeating pattern. So it is the definition of an irrational number. So to say it's rational is false. -2 is an integer, that's true. Integers are whole numbers. They can be positive or negative, but they're whole numbers. -2 is a whole number, no fractional decimal part. And 2/3 is an imaginary number. Well, we just said that real numbers are everything but this. This is the definition of an imaginary number, trying to square root a negative. 2/3 isn't trying to square root a negative, so 2/3 is not an imaginary number. 2/3 exists, it's real. Solve the following. 2 negatives multiply to give a positive. -4 times -5 must therefore be a 20. -3 -7, this is not the case of 2 minuses making a plus. 2 minuses make a plus when we times 2 numbers like we just did, or if I divide 2 numbers, or if we have something where the 2 negatives are right next to each other. 3 minus -5, that'll be a 3 plus 5, but this is none of these situations. It's not times, it's not divide, and the 2 signs are not next to each other. This just says I went 3 steps backwards and then 7 steps backwards. What have I done altogether? I've gone 10 steps backwards. -30 divided by 6, that is one of these situations. A minus and a plus make a minus. And how many 6's are in 30? There's 5 of them. -8 plus 5 is back to one like this. It's 8 steps back, but it's 5 steps forward. So on the number line, 8 steps back might have taken us back here. 5 steps forward doesn't take us to positive yet. 5 steps forward from a -8 will leave us at a -3. Then we've got a BODMAS question, or order of operations, which we say B, or brackets, is the most important thing. So that leaves us with, I'll write it down here, 8 divided by, do what's in the brackets, 4 minus 2 is 2, -2 by 3 squared. No brackets left. The next was O, which we can say stands for of, square root of, or power of. And we've got a power of here. 3 squared means 3 times itself. So it's 8 divided by 2 minus 2 by 3 squared, and 3 by itself is 9. Now I've got a division and a multiplication. They're equal importance, and they can both happen independently because there's only a minus in between. 8 divided by 2 is a 4, minus 2 9s is 18. Now I've got a small number of 4 minus a big number of 18. I'm definitely ending up negative. And 4 forward, but 18 back leaves me 14 back. Remember that little trick we can do. If we've got a 4 minus 18, something we know is going to become negative, small minus big. I already know it's negative, and the gap between them is going to be the same as saying the other way around. 18 minus 4. So if I am doing a subtraction between 2 numbers that I know is going to end up negative, the number part of it is the same as just thinking this minus this. If that shortcut helps, great. If not, ignore I said it. Now on this next one, we've got no brackets, but we sort of do. There are implied brackets. Under a square root sign, there are implied brackets. There's also implied brackets on the top and bottom of a fraction sign. So it's like we've got brackets within brackets here. But the most inner brackets is under the square root sign. So that's what I'll focus on first. I'll leave all of this. Underneath the square root sign, the minus doesn't outrank the times. Times still comes first, so I've got the 20 minus, and the 2 by 2 is 4. So that's all I've done so far. I've still got to complete what's under the brackets here. These implied brackets, that is. 8 minus, well, root 16 that becomes. Note on the proper mid-semester, I've left more room than I have on this. Just for printing's sake, I thought, don't need to space it out that much. Root 16 is asking what times by itself to give 16. The answer to that is 4. Square root of 16 is 4. We end up there with an 8 minus 4, which is a 4 on a 2. How many 2's in 4? There's 2. Nice. Which of the following is equal to minus 5 squared? Well, minus 5 squared means minus 5 times minus 5, because the squared here is saying everything in these brackets is getting squared. This times by itself, and if two minuses are being multiplied, they become a plus, and 5 5's are 25. A. Which of the following laws is always true? X plus y plus z equals y plus x plus z. That's saying if they're all additions, we can change order. That's true. I can think of 2 plus 3 plus 4 equaling 3 plus 2 plus 4. It doesn't matter which order I put it in. A is definitely true. Division, that doesn't work. I'm not going to say 20 divided by 4 equals 4 divided by 20. 20 divided by 4 is number 5. 4 divided by 20 is 4 on 20. In other words, a fifth. Of course, 5 doesn't equal a fifth. B is definitely wrong. This one is purely made up. We have a distributive law. If that was a times and that was a plus, then I'd say it's x times a y plus x times a z. But this doesn't say that. That's garbage. A is the only true law there. Standard algorithms, not mental addition. That's just our standard way to add up from a long time ago. For example, 1427 plus 2485. Don't get messy, boy. 7 plus 5 is 12. We've got 10 here plus that 1 is 11. We've got 4 plus 4 is 8 plus 1 is 9. And 2 and 1 is 3. Done. The 27 by 86. Standard multiplication, where we start at the 6 and we say 6 7's are 42. I stay at the 6 and say 6 2's are 12, plus that 4 is 16. If there's another number, I'd put the 10 up there, but no. I just write down 162. I don't need that little crutch figure now, and basically I've finished with the 6. Now I'm going to do everything with the 8, but it's not really 8, it's 80. So I'll put the 0 there. 8 7's are 56, which puts the 6 down there and the 5 up here. 2 8's are 16, plus the 5 is 21. Now if I add them up, I've got a 2, I've got a 12, I've got a 3, and I've got a 2. Okay, next we've got 3002 minus 194. If we do this with the new method, which should be the new step method really, because of your ages, 2 minus 4 I can't do, so I need to steal off that, but there's nothing to steal. So I'll keep moving back. So instead of stealing a 10 from here, I'm stealing a 10 from these 300 10s. The 300 comes back to the number just prior to it, 299. And I put the 10 there to make this a 12. So really, that is the number 3000, which is 300 10s. I've stolen this 10, so I've only got 299 10s there now. 12, so that 10 and that 2, that 12 minus 4 is an 8. 9 minus 9 is a 0. 9 minus 1 is an 8. And 2 minus nothing is still that, 2. Note that we could have done it the old way. We don't need to know both, but just in case you prefer the other way, here is where I make that into a 12, but I put a 1 down there. I've added a 10 there and I've added a 10 there. It's equal addition. If I add a 10 to both numbers, the question will still give me the same answer. 12 minus 4 is an 8. Again, I need to make that into a 10 and put 1 down here. 10 minus 9 minus 1 is 0. I need to make this into a 10. 10 minus 1 is 8. And 3 minus 1 is 2. Optional, but there if you want to do it that way. This is a division. Our division algorithm is saying 18259 divided by 6. Lock in that back to front thing when we do the division algorithm, because it gets confusing later when we're doing things like 3/5. If we want to put that into a division algorithm, it seems odd putting the small number under there, but it doesn't matter whether it's big or small. The top number goes under here, and what you're dividing by is out the front, and later on we'll do that, but that's later on. Here, so the first number is under here, so it's like they swap places, and the 6 is what we're dividing by, and that goes here. 6 is into 1, can't get any 6's out of a 1. 6 is out of an 18, I'll get 3 of them. 6 is out of a 2, I can't get any 6's out of a 2, haven't used the 2 yet, it's still remaining there. 6 is out of 25, well 6 4s are 24 with 1 left over. 6 is out of a 19, well again 3 6's are 18, remainder 1. Now remainder also gets divided by this. We write it as 3043 and 1/6. Write the face, place and actual value for each digit requested in the table provided. The digit 2 in 1320, well the face value of that 2 is a 2. It's not in the units, it's in the tens column. And face times place always equals actual. It's really worth a 20. We know that when we say it. We say 1320. It's base 10, so it's just normal stuff. The digit 0 in 10,421 has a face of 0. Not where is it, what's its face look like? It looks like a 0. It's not in the ones or the tens or the hundreds, it's in the thousands column. And face times place is saying we've got no thousands, and 0 times 1,000 is 0. Which of the following is the best estimate? Now remember with these estimates, it doesn't really matter whether you round up or down, it's just something that's close, and these answers are far enough apart that we'll get there with whether we round up or down. Just say I round them both down, because they're both, like the 6 is only followed by a 2, I'll call the 626 roughly 600. 348, I'll just call it 300. If I do that, say an estimate of 600 by 300, well 3 6's are 18, and I've still got 1 2 3 4 zeros. 1 2 3 4. So that may not be the exact answer there, like I'm looking at 18,000, but 18,000 is very different from 180,000. 24,000 is 2. There's 1.8 million, no way. But can you see that 180,000 is close to 240,000? That's the best estimate. Sure, it's not perfect. What's that come from? That's come from, someone said 600 times 400. 6 4s are 24 is 0 0 0 0. So that is what that's come from. But it's still comparing an estimate of 180,000. It's much closer to this than anything else. 2-digit number with 4 zeros. It's definitely D. Use a long division algorithm. We're being forced. We've got to use a long division algorithm. 39952. Again, it's like I'm writing it backwards. Divided by 16. I can choose to write those 16 times tables down here. Let's see how we go first. The numbers may not get big. 16s into 3 is not going to happen. 16 into 39. Well, 2 16s is 32. That's as good as we'll get. Every time I put a number up here, I write down what 2 16s is. And I'll do the subtraction, not in my head, but on the paper. 39 minus 9 minus 2 is 7, 3 minus 3 is 0. The gap there was 7. Bring down the next number. Now I'm saying how many 16s out of a 79? Starting to think, oh, maybe I should have done 16 plus 16 plus 16 over here. But let's do a trial and error, use multiplication. There's 4 20s in that, maybe there's 5 16s, let's check. It's just a guess. 6 5s are 30, 1 5 is 5, plus 3 is 8. 80 is too many. I can't get 5 16s out of that, I've only got 79 to play with. It must be 4 16s. 6 4s are 24, 1 4 is 4, plus 2 is 6. So 4 16s, and we write it down again, don't do the subtraction ahead, is 64. 9 minus 4 is 5, 7 minus 6 is 1. Bring down the next number. 16's into 155. Well, I know 10 16s is 160. That's too many. I reckon 9 16s. I could just take a 16 off 160, but I'm just going to do it this way. 6 9s are 54. 1 9 is 9 plus 5, so we've got 144. So I can get 9 16s is 144. Why are you stopping doing that? And that leaves me with a gap there of 11. The last number to bring down is 2. So I'm saying how many 16s out of 112? Well, 5's too few, 9's too many, somewhere in the middle. Let's just look at what 16 by 7 is. 6 7's 42. 1 7 is 7 plus 4 is 11. Oh, right on the money. 7 16s is 112. My remainder is 0. I don't need to write anything because the remainder is, it went in evenly, as in it this number was divisible by 16. Not the question, just saying's all. Write down the steps that could be taken to calculate the following mentally. Water, please. Thank you. So if I were to just do my normal algorithm here and go blah blah blah. No, it's not asking for the algorithm. It's saying if I was doing this in my head. Real life, if I was doing this in my head, no pencil, paper, I would think of 48 plus 30 plus 5. I'll probably just split those two, because 48 plus 30 is not too hard to do. That's 78. And 78 plus a 5. Middle, I'm thinking 78 plus 2 plus 3. I don't have to write to this extent, but I'm just writing out the way I'm thinking of it through, because I know that's 80 plus a 3. That's 83. You don't have to write it out so much. I mean, another way I could say it's like 48 plus, it's easy to add 40, but if I add 40 I've added 5 too much. I could do that, because 48 plus 40, that's easy, that's 88. 88 minus 5 is 83. Hey look, there's lots of ways to do it. There's a couple. 6 by 48, we're going to have options here again, but again, don't just do the 48 by 6. Do it at the side if you want to check the answer, not a bad call, but make sure you put a line through it just to show that that's not what you're asking to get marked, that was you just checking. What I might do is split the 48 into a 40 plus an 8. So I'm saying it's 6 of the 40s and 6 of the 8s. So I'm going to think of it as 6 by 40 plus also a 6 by 8. Well, 6 4s are 24, and put that 0 on, I just ignored, plus 6 8s are 48, and 240 and a 48 makes 288. That was a good technique. Another way I might have done it, you only have to write one answer, but I could think 650s would be easy, round 48 up. I could say it's the same as 650s. The problem is I've done too much. I've done too many. And since I've done 6 of the number, I've done 6 of the bigger number, I have to take the gap off, but 6 of them. Okay? 48 is 50 minus 2. So I times 50 by 6. By doing that, I times that extra 2 by 6 as well, so I've got to take it off. 6 50s, well, 6 5s are 30, plus that 0 is 300 minus 12. Take off 12 off 300. Take the 10 off, it becomes 290. Take off 2, it becomes 288. Just note, if it helps, I could have put this step in first. Just replace the 48, sorry, with a 50 minus 2, because that's a 48. Then I did 6 times 50, which is that, and 6 times minus 6 times 2, which is that. You don't need every step in here, but well, it's not a lecture, David. Don't explain everything. Okay, write down the steps that could be taken to calculate 986 minus 888 mentally. Okay, mental steps. So for subtraction, well, there's the equal addition method. I could do that. I could turn this into a 900. If I add 12 to that, that would become 900. If you're going to add 12 to that, that's okay, but you could add 12 to the other one as well. This only works for subtraction. You can't just add 12 to an addition question, because, well, you'll change it and it won't work. It's only subtraction questions where you add a number to both and the distance between them stays the same. 986 plus 12 will be 998. So I'm saying the answer to this is equivalent to 998 minus, add a 12 to that, well, that's a 900. That's not a very good minus. 998 minus 900 is 98. Nice. Another way we could have done it, I could have taken off an 800 and then an 80 and then an 8. Or I could have walked my way from this one to this one. I don't mind this technique. We're doing subtraction, you're finding the gap between the two numbers. So I could think of walking from 888 to 900 would be 12 steps. To walk from 900 to 986 would be 86 steps. 12 plus 86 is 98. Rather like that. Anyway, you don't have to like it. I hope you like it. Next one. The first four place values for base 12 numbers would be, everything starts with a 1. Option A is gone. And then we multiply by whatever the base number is. 1 by 12 is 12. That's okay. 12 by 12 is not. We don't plus them. 1 by 12 is 12. 12 by 12 is 144. We all know that 12 by 144 is 1728. Not. Let's check. 144 times 12. Make sure this isn't tricking us with that one. 2 4s are 8. 2 4s are 8. 2 1s are 2. Now I'm going to move to this. It's a 10 really, so I'm going to put a 0 there. 1 4 is 4. 1 4 is 4. 1 1 is 1. 8. 8 and 4 is 12. 4 5 6 7. 1. It's true. C. Convert the following non-decimal numbers to base 10. So we can automatically do the boxes here. We can do, if it helps, you can do face, place, actual. Anytime you're getting asked to convert a number from a non-decimal base, face, place, actual helps us. Because the face value of our digits are a 2 and a 2. The place values is like the boxes we've been doing. Well, it's like the previous question. What are the place values is what goes in these boxes. We always start at the right with 1. Every base starts counting in units, and then we multiply by what base it is. In this case, it's base 3. 1 by 3 is 3. My next box would be 9, but I only need 2 columns because I've only got 2 digits. Actual is always face times place gives actual. 2 3s are 6. 2 1s are 2. So this digit is actually worth 6. This digit is actually worth 2. The total amount these actual values add to is 8, and that is the number in base 10. I don't have to write 10 there. If I write nothing, it means I'm in base 10, but I'm just clarifying that the actual value of 2 2 in base 3 is 8 in base 10. We've got a couple of practice ones here. Let's look at this one. 1 2 3 4 5. Okay, we've got 5 digits. Face, place, actual. So in the place, I need 1 2 3 4 5. I know my face values are 1 1 0 1 0, because that is the question. I'm in base 2. I'll still start with a 1, but I'll keep timesing by 2. Don't accidentally add them. 1 times 2 is 2. 2 times 2 is 4. 2 times 4 is 8. And 2 times 8 is 16. I kept timesing by 2, so that's right. Now my face times place gives actual. 1 16 is 16. 1 8 is 8. 0 4s is 0. 1 2 is 2. And 0 1s is a 0. The sum of all my actuals is 16 plus 8 is 24 plus 2 is 26. Again, it's base 10. I need face, place, actual again. I only need 3 boxes this time. The face values are a 2, a 5 and a 7. And since it's base 8, I'll still have 1s there. And I'll just pause for a second. Oh, I won't pause.
Oh yeah, let's put in the box.
Oh good, thank you. Alright. So it's base 8, so I'll get this 1 and I'll times by 8 to get 8, and I'll get 8 and times by 8 again to get 64. Now my face times place giving actual. 2 64s is 128, 5 8s is 40, and 7 1s is 7. So my sum's getting bigger. 128 plus 40 plus 7. I'll just shortcut and call it 47. 7 and 8, we've got 15 there. 4, 5, 6, 7, 1. There it is. They sum up to 175 in base 10. Yoink. Stop saying that. Is that number divisible by 4? Briefly explain your answer. Well, if we use our divisibility test, all I need to check is the number formed by the last 2 digits. The 4 divisibility test says if this number is divisible by 4, then the whole number is. 26 isn't divisible by 4. 6 4s are 24, 7 4s are 28. 26 if divided by 4 would give me a remainder. No, because of what I just said. Don't do that in the exam. Write the reason. Right, because the divisibility test by 4 blah, blah states that whatever number the last 2 digits form must be divisible by 4. The other way I could have done it, if I didn't know my divisibility test, is just do it by definition of divisibility. This is divisible by 4 if I get no remainder. 4 into 1, nope. 4 into 13, 3 4s are 12 with 1 left over. 4s into 12, 3 4s are 12 with 0 left over. 4 into 4 goes 1. 4 into 2 doesn't happen with that 2 left over. 4s into 26. Well, 6 4s are 24, remainder 2. The fact I've got a remainder says no, it's not divisible by 4. Using divisibility tests or otherwise, determine which of the following is equivalent to this huge number in a mod 5 system. To convert that number to mod 5, I could divide the whole thing by 5. And it's a big number, it's going to take me a while. But divisibility tests, I know that multiples of 5 in 0 or 5. I can see that the closest multiple of 5 under this number will be blah 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 blah. It will end in a 5. That will be a multiple of 5. And any multiple of 5 in a mod 5 system lands you wherever you started. It's like multiples of 7 when you're counting days of the week. In 7 days, it's still today's day of the week. In 14 days, in 21 days. So if I said 22 days, I only care about that one number extra to a multiple of 7. Same here, I only care after all of this with ending with a 5, I'm still on the same day, and I care about that remainder of 1 more. There is my one gap. It's B. 1248 equals mod 11. We don't have mod 11 divisibility tests. I mean number 11 divisibility tests. We've got to do this like we've had in quizzes. We convert this number into that mod by dividing by the mod number. 11's into 1, nope. 11's into 12 goes once with 1 remainder. 11's into 14 goes 1 with 3 remainder. 11's into 38, well 3 11's are 33, leave me a remainder of 5. In modular arithmetic, we only care about the remainder, not how many times we go around the loop. There it is there. On Christmas Day in 2014, it was a Thursday. It's true. Use modular arithmetic to calculate the day of the week that Christmas will fall on in 2015, given that there is 365 days between them. Or maybe given that there are 365 days between them. Don't care. Basically, it's asking us like that previous question. This question could have been 365 is equivalent to what in mod days of the week? 7. Okay, if I go forward 365 days, it's equivalent to, make my life easier, get that 365 and divide it by 7. 7's into 3, nope. 7's into 36, well 7 5s are 35 with 1 remainder. 7's into 15, there's 2 7's of 14, remainder 1. In other words, it's saying walking forward 365 days, it's 52 weeks, which lands me on the same day, plus 1 day. So the plus 1 day is all I care about. We're adding on to a Thursday, plus 1 day takes me to a Friday. Be very careful with these questions. Sometimes it might be talking about back in time. If this was a question about what was Christmas Day back in 2013, moving 365 days is still equivalent to moving 1. But if I was going back in time, I would have gone from Thursday back to Wednesday. But no, this was forward in time. Just saying. Which of the following is not a common factor of 16 and 32? They're both even. They've both got 2 in them. 2 8s are 16. 4/8 is 32. 16 is a factor of itself, and 2 16s make 32. They all are. They're all factors, common factors of both. The lowest common multiple of 20 and 24, that's like the denominator thing. That's like the question of 1 on 20 plus 1 on 24, and we're trying to find the number that is a multiple of both. I could look at all the multiples of 20 and all the multiples of 24, but our tactic has been walk to the bigger one, see if it'll do the job. Is 24 a multiple of 20? No way. Multiples of 20 are itself 20, 40, 60. I'll just write down multiples of 20, 20, 40, 60, 80, 100, 120, 140, so on. I want one of the multiples of this to be the same as them. 2 24s will be 48. It's not the same as any of these. Add another 24 into that. In other words, 3 24s. Well, take me to 72. Not the same as any of them. Add another 24. 20 will get me to 90. 4 will get me to 96. But the next one looks good. If I add a 24 to that, 4 will get to me 100, and 20 will get to 120. There's the lowest common multiple. The first time a multiple of 20 and a multiple of 24 with the same number is at 120. As for the highest common factor, remember factors go inside stuff. And here, the largest factor in 30 is itself. If I was to list factors of 30, I'd say it's 1 times 30, and it's 2 times 15, and it's 3 times 10, 4, it's 5 times 6. There's all its factors. So I start repeating myself, I start going past that, I don't reach another one till 10 by 3, and we've already counted it. The highest factor of 30 is 30, and 30 is a factor of 120, because 4 30s make 120. This number itself is the highest common factor. Both 30 and 120 have a common factor of 30. So there we go. A tunnel is being constructed from by two work teams. One team has constructed 1/3 of the tunnel from the west, and the other has constructed 1/4 from the east. So what's this left? Well, it's one tunnel. The entire tunnel minus 1/3 has already been done, minus 1/4 has already been done. I could do it in two parts. I could do the 1 minus 1/3 first if I was more comfortable with that, and say 1 minus 1/3 is 2/3, and then do that. And then I'll use a common denominator of 12 and say the 3 got times by 4, so that 2 had better get times by 4. The 4 got times by 3, so this 1 had better get times by 3, and I get an answer of 5/12. I could have done it all in one go if I wanted. 1 minus 1/3 minus 1/4. Think of 1 as a 1 on 1. The lowest common multiple of a 1, a 3 and a 4 is still a 12. That 1 got times by 12, so that 1 get times by 12. 3 by 4, 1 by 4. 4 by 3, 1 by 3. 12 minus 4 is 8, minus 3 is 5. Either way, what fraction of the tunnel is still to be constructed? That. Show working. Look. Fill in the boxes to complete these equivalent fractions. So making this fraction be the same as that. Oh, I accidentally deleted the box. On your sheet there'll be a box there, because I'll fix that after this. What happened to that 16 to get it down to 4? This is only what you do to a fraction, top and bottom, is times and divide. I'm not going to say like minus 12 here, minus 12. That doesn't work. Times works because, say I times by a 4 on the top and a 4 on the bottom, it's like just times by 1. Again, not a full lecture. 16 gets divided by 4 to become 4, so do the same here. How many 4s are in 60? May not even know. But remember, it's just saying how many 4s are in 60 is 60 divided by 4. 1 in 6 with 2 left over. That tells me. And the other way is I can say, how does 15 get to 45, or how does 60 get to 45? It's easier to say 3 15s make 45. If I'm going to times that by 3, I'd better times this by 3. 4 3 is 12. What's a reciprocal of 2 3/4? Reciprocal is like when we divide by a fraction, we take the reciprocal and multiply instead. It's flipping it upside down. But with all of these things, we get our mixed fractions and make them improper. 2 by 4 is 8, plus 3 is 11. That's not the answer, that's just 2 3/4 is mixed fraction. 11/4 is that as an improper. Hence the reciprocal, that's just a therefore sign. Therefore the reciprocal is equal to 4 and 11. Is that one flipped? Evaluate leaving answers in simplest form. They've all got a denominator of 8. It's nice. All I've got to do is 7 plus 5 plus 3 plus 1. 7 plus 5 is 12, plus 3 is 15, plus 1 is 16. That looks good, but it says simplest form. 16 on 8 is just the number 2. How many 8s in 16? That's its simplest form. Here, okay, I've got mixed again, so I'm going to make it improper. 2 5s is 10, plus 4. 2 and 4 fifths is 14 on 5. I can check that if I want. How many 5s in 14? 2 with 4 left over. All good. 1 10 is 10 plus 3, 13 on 10. Again, how many 10s in 13? 1 with 3 left over. Now, the lowest common denominator here, I walk to the big one, see if it'll do the job. 10 is a multiple of 5. That's great. I can leave that alone and only change this one to a 10. 5 times 2, so 14 times 2. It's a 28 on 10 minus a 13 on 10. 28 minus 13 is a 15 on 10. 15 on 10, I can bring that down further. It just says leaving answers in simplest form. So I can say there's 5s in common, 2 5s there and 3 5s there. 3 on 2 would be a perfectly fine answer. If you made it mixed, that'd be fine as well. How many 2s in 3? There's 1 with 1 left over. That'd be fine as well. I mean, if you said 15 on 10 is 1.5, a shift of the decimal, that'd be fine. They're all the same answer of 1.5. Evaluate 3/4 plus 5/6, leaving answer in simplest mixed fraction form. Okay, I need a common denominator. I could do 6 4s are 24, but I'm going to walk to that one and see, is 6 a multiple of 4? No, it's not. What about 2 6s? Is 12 a multiple of 4? You bet it is. So I'm going to use lowest common denominator of 12. 4 got times by 3 to get there, so 3 will get times by 3 to get to 9. There's a plus in the middle. That's 6 got times by 2, so 5 will get times by 2. All I've got is a 19 on 12. And this wants simplest. It's already in its simplest form. The numbers are as small as possible. But mixed fraction means a mixture of a whole number and a fractional part, which asks the question, how many 12s can I get out of 19? 1 12, but the remainder left is 7. And we put 1 and 7/12. Question 5, multiplication. When fractions are multiplied, we can cancel. Like that 1 7 and 2 7. 7 14 was nice. What about the 3 and the 12? A single 3 there and 4 3s there. That works. What about that 4? I've got a single 4 there and a single 4 there. All I've got left on the top is 1 by 1 by 1. On the bottom is 7 by 1, which is 7. And then by 2, which is 14. Done. When I've got mixed fractions in here, I want to make them improper. 1 2 is 2 plus 1 is 3. We already saw before that 3 on 2 and 1.5 are the same thing. Dividing by a fraction, we don't really do it. We turn it into a times and we invert. Now that we've got times, I can cancel if I want, and I can see I've got a single 3 and a single 3. And 2 and a 4 as well, a single 2 and 2 2s, 1 by 1 on the top and 1 by 2 on the bottom. Drink. Stop it. Lucia buys 3 pizzas for her family and half of everything is eaten. I'm going to take this with a picture first. Here's 1, 2, 3 and a half pizzas. Remember, a diagram is acceptable working for these questions. It shows you understood it. Half of everything is eaten. Alright, why did I write 3.5 if it's only 3? She bought 3 pizzas, sorry, and half of everything is eaten. Alright, half of that pizza's gone and this one. 1.5 pizzas is remaining, 1.5 pizzas is gone. The next day her kids eat half of what was left. Alright, I might split it that way. That's gone and that's gone. Lucia's husband then eats half of what was left after the kids. Alright. At the moment I'm just going to label this. At the moment there's a quarter of a pizza there and a half a pizza there, but half of all pizzas going again. So that's getting rid of this. Now I've only got a left quarter. Half of this is going. It's like splitting it into, it's like the pizzas now become 1/4 into an eighth and an eighth, because there's 8 bits this big. So if half's gone, all I've got left is a 1/4 piece and an eighth piece. A 1/4 plus an eighth. Well, I walk to the biggest denominator of 8, and that will do. 4, a multiple of 4 is 8, so leave the plus 1/8 alone. Times by 2, times by 2, 3/8. Was that the question? What fraction of a pizza is left for Lucia? That's it. If I didn't like diagrams for that, I could say, here's the 3 pizzas. Half of everything is eaten. So if we're halving it, it means half is eaten and half remains. 3 times a half, consider 3 to be a 3 on 1, equals 3 on 2. That's how much pizza was eaten. That's also how much remains. That remaining pizza, half of that gets eaten by Lucia's kids. So 3 on 2 gets times by half as well. 3 by 1 is 3 and 2 by 2 is 4. So in other words, 3/4 got eaten and 3/4 is also left. That's the amount of pizza that Lucia's husband walks up to and says, I'm going to eat half of it. So he eats half of it, and again half is left. 3 times 1 on the top and 2, 4, so 3/8 is what he ate. He also left 3/8 for Lucia. Same answer. Many ways to do it. There's 2. Which of the following is equivalent to 0.006? Well, many approaches, but I'm going to approach from the decimal topic we had, which said put all of these digits on top, and however many decimal places were here is how many zeros are on the bottom. 3 decimal places, 3 zeros. The other way to think is that's the 10th column, that's the 100th column, that's the 1000th column, and that face value of 6 says I've got 6 of these 1000s. That's definitely the answer. It's not that. Maybe it simplifies down. Half the top is 3, half the bottom is 500. Is that there? Yeah, it is. We're done. Which of the following is equivalent to 3 on 20? I know I've always got the fallback option. Any fraction can be divided. That literally says 3 divided by 20, which is what this says. 3, how many 20s can I get out of 3? None. How many 20s can I get out of a 30? 1 with 10 left over. How many 20s can I get out of 100? 5. There's the answer there, C. Another way I could have done it is if you can convert a fraction's denominator into a 10 or 100 or 1000, like here, timesing by 5 easily makes it 100. 3 5s is 15 on the top and 25s is 100. And let's undo this operation from up here. How many zeros I've got on the bottom is how many decimal places I have. So I should have 2 decimal places, and there they are. What is 5 on 33 written as a recurring decimal? Show working to justify your answer. I know it looks tempting to try and make that 100, like times 3 makes it 99 and we're close, but close isn't very mathy. The word mathy isn't very mathy. But let's go to this fallback option. Every single fraction can be done. That means 5 divided by 33. We said before that the division algorithm is like the wrong way around. That's how we write 5 divided by 33, and let's give 5. It says recurring decimal, so I'm already aware that I'm going to need some zeros there. 33 is into 5, of course not. 33 is into a 50, only one of them. The gap would be 17. I could do this as a long division, but I choose not to. How many 33s can I get out of 170? Ugh, I've got to do some trial and error here. 5 30s is 150. I'm going to try 5. 33 by 5, I reckon that'll get me close. 3 5s are 15. 3 5s are 15 again, plus 1. 165 is almost 170. Not getting any better than that. 5 33s is 165, so the gap, the remainder is 5. Now I'm asking myself a question I've already asked myself. I'm in a loop. 33s into 50 was 1 with 17 left over. 33s into 170 was 5 of them with 5 left over. On and on and on. 1 5 1 5 1 5. The dots, it's the 1 5 that's repeating, but you put the dots over the first time they repeat. The 1 and the 5 repeat from the very start. There's my answer. Or 0.15 with a line above both if you prefer. Okay, decimals. all we want to do is align the decimal point. There's a 3.4 and a 0.856. I'm going to fill that with zeros just to help me stay in alignment. 0 plus 6 is 6, 0 plus 5 is 5, 4, 8 is 12. The decimal point's aligned to a decimal point in the answer, and 3 plus 1 is 4. Yep, happy. I'm going to do the same tactic down here with a subtraction. I've got a 7.2 and a 0.09. Here it's not just a nice to have. I really definitely want to have my same number of decimal places. Because 0 minus 9, I'm going to do this with the new method, which is saying still from there take that down by 1 and that 10 goes there. So really I've split 20 into a 10 and a 10. 10 minus 9 is 1, 1 minus 0 is still 1, and 7 minus 0 is 7. Done. Last question. Stop talking soon. Our method in multiplying decimals was ignore the decimal point initially. That's like just the number 5 times the number 7. How many decimal points did I ignore? 1 there, 3 there. I ignored 4 decimal points. So I better give this 4 decimal places. Not 4 decimal points. I ignored 4 decimal places. I'll give my answer 4 decimal places, and there it lies. 0035. Decimal division, we do not do the same. We write them as if they were fractions. We put the left over the right. Then we make the denominator a whole number. I don't care about the numerator being whole, but I can see it needs to be times by 100, which is the same as moving the decimal point 2 places to the right. So that becomes a 3, and after 2 moves that becomes 0.24. Now, decimal division is fine if you're dividing by a whole number, and 3 is a whole number. So 3's into 0 doesn't happen, 3's into 2 doesn't happen either, and 3's into 24 goes 8 times. There's my answer, 0.08. A pizza delivery driver earns $7.20 per hour and $1.40 per delivery. How much would the driver be paid if he worked for 4.5 hours, so they go together, 4.5 hours at $7.20 an hour, and 10 deliveries at $1.40 per delivery? I'm not going to bother writing the dollar signs. I'm just going to call it $7.2. You could call it 720 cents and work in cents if you want, but I'll stick with the decimal theme. $7.2 times 4.5, because he's done 4.5 hours of that. Plus he's also going to get paid $1.40, I'll just call 1.4, 10 times. 1.4 for each delivery, 10 deliveries. Equals 7.2 times 4.5. I'm going to ignore the decimals and work out what is 72 by 45. 2 5s are 10, 7 5s are 35, plus 1 is 36. Now it's 4, but it's 40 really, so I'll put the 0 there. 2 4s are 8, and 4 7s are 28. I'm going to add these up. I've got 0 and a 14, 12 and a 3. So I get 3240. 3240. I ignored 1, 2 decimal places, so I'll give the answer 2 decimal places. So it's 32.40 or 32.4 or $32.40 plus a number times by 10 just makes it one movement bigger. So $1.4 becomes $14. So I'm adding $32.40 plus $14. My answer is $46.40. In a small garden of flowers, there were 4 red flowers and 21 blue flowers. What percentage of the flowers are red? Percentages compare what we're discussing, which is 4 red flowers, over the total number of flowers, not just the 21. It's 4 over the total. 21 plus 4 is 25. 4 of the flowers out of a total of 25 flowers were red. It said percentage, so I'll times by 100 over 1. Let's do I could do 125 there and 4 25s there. That's pretty quick. All I've got on the bottom is 1, and on the top is 4 by 4. I've converted it to a percent. It's good old 16%. My water bill of $220 is about to increase by 35%. I could approach this by saying, if there was no rise, I would have paid the full bill over 100%. but it's gone up by 35. So I'm going to pay 135% of $220. Mathematically, of is a times 135% times 220 as a whole number over 1. Let's get rid of a 0 and a 0. We've got 5's in common here. There's 2 5's there. How many 5's are in 135? Am I still on the page? 5's into 1 goes 0. 5's into 13 goes 2 with 3. 5's into 35 goes 7. 22 and a 2. Let's halve that and halve that. The answer to this is going to be whatever 27 times 11 is. 27 times 11, got 1 7 and 1 2. Then this 1 is actually a 10, so I'll put a 0 there. 1 7 and 1 2. When I add them, I get a 7 and a 9 and a 2, which gives me a result of $297. The other way I could have done is said, well, the bill's going up by 35. What's 10% of this bill? 10% of this bill is a reduction of one movement of a decimal point, which is $22. So let's add 10% and 10% and 10% to get to 30%. So that's at 22 and that's at 22. All I need is extra 5%, half of 10%, half of 22. Now you can see I've added 10 plus 10 plus 10 plus 5 is 35%. And all of these, 22, or let's just add them up manually, 2, 4, 6, 7, 2, 4, 6, 7. So it's saying the price rise is $77. 220 plus 77 is a 792, $297. Same. I purchased a DVD for $18 after it had been discounted by 25%. So I'm not going to say what's 25% of $18 because the discount was calculated off the old price tag. And that's what I want to know. I only know the new price tag. But like the logic before, I was going to pay full price for this DVD, but it got discounted by 25. Full price is 100%. 25% less than that, I only paid 75% of the value of this DVD. And that cost me $18. The questions asked me what was full price before the sale. A nice middleman between a 75 and 100 is the same question as what's the highest common factor. What's a nice factor between 75 and 100? They got factors of 5. I could use that, but think of 25. 25, if you spot it, is great because all I've got to do is say how many 25s are in 75. In other words, I've divided 75 by 3 to get down to 25. Just do the same the other side. So 25% of the original price would be $6. How do I get from 25 to 100? I times by 4. Do the same on the other side. 6 4s, that's $24. The original price of the DVD was $24. Ian bought a surfboard for $240 and sold it later for $180. What was his loss as a percentage of his cost price? Firstly, what was his loss? 240, 180, he lost $60. As a percentage of his cost price, well, it says he bought a surfboard for $240. That was what it cost him. We're comparing $60, I won't worry about the dollar symbols, 60 to 240. Okay, and it says percentage, so I want to times by 100 on 1. Let's lose a 0. Let's say between 10 and 24, let's halve them both. Call it a 5 and a 12. 12 and 60, well, there's 5 12s in 60, a single 12 here and 5 12s there. All I've got on the bottom is 1 by 1. On the top is 5 by 5. I've made it a percent, 25%. Notice for this one and the last one, once you've done it, you can check what is 25% of 240 and you'll find out that it's $60. On the previous one, I could now say what's 25% of the original price. A quarter of that would be a $6 discount. $6 discount would take me to a discounted $18 price. So I can still check stuff. A car uses 5.4 litres. I'm just going to write down. 5.4 litres will get me a distance of 90 kilometres. What I want to know is the fuel consumption of the car in litres per 100 kilometres. I've got info about 90 k's. I want info about 100 k's. I can see it's going to be, 6-ish litres, but I want an accurate. Again, I want a highest common factor, a number I can bring 90 down to, and then easily go up to 100. And the highest common factor I can see is 10. They've both got 10s in it. Nice number to work with. From 90 kilometres down to 10 kilometres is a divide by 9. From 10 up to 100 is a times by 10. I've just got to do the same on the other side. 5.4 litres divided by 9. Remember, it's okay to divide a decimal by a whole number. 9s into 5 doesn't happen, and 6 9s are 54. So it must only take 0.6 of a litre to drive 10 k's, and then it said times by 10. 0.6 times 10, it was 6 litres. Good guess. Not really. Okay. Oh, last one. It's nearly beer o'clock. 7 divided by 16. Does 16 become 100 easily, or 1,000 easily? I don't know. Truth is, it becomes 10,000, but it's just not nice. If it was a 20 or a 25, I'd times it by 5 or 4, respectively. Here I'm just going to say, I don't know. 7 divided by 16, let's just do it. And stick some zeros there and see how many we need. 16's out of a 7 is not going to happen. 16's out of a 70 though. Well, let's have a guess. 5 16s, that'll be a 50 and a 30. That'll be too many. 4 16s, I reckon. Let's check. 16 by 4. 6 4s are 24. 1 4 is 4. Plus 2 is 6. That's as good as we'll get. 4 16s. Let's be nerds and do long division. 4 16s are 64. The gap left, subtraction here is 6. Bring down the 0. 16s into 60. Well, it's going to be less than 60. It's going to be about 3. 16 by 3. 3 6s are 18. 1 3 is 3 plus 1 is 4. 3 16s is 48. So 3 16s are 48. My gap left is 12. Bring down 0. Ugh. 16s into 120. Let's take a stab at it. Let's try around about 7 16s. 7 6s are 42. 1 7 is 7 plus 4 is 11. 112 plus 16 goes above that. That's as good as we'll get. 7 16s is 112. 120 minus 112 is 8. Last one down. 16s into 80. Let's try about 5. We already did this before. I did it in my head. 5 6s was 30. 1 5 is 5 plus 3 is 8. Right on the dot. So I don't need any more zeros, and I've already got 5 16s are 80. I've got a remainder of 0, so there's no repeater or anything. I'm done. That was the answer. Not many marks for this. In the actual mid-semester, there's probably more. Make the revision paper a little bit tougher, or maybe even less marks for certain things, just to make the real ones seem nicer. There's the decimal, 0.4375. Fractions and decimals become percents by timesing by 100. Percents go back to decimals by dividing by 100. So to decimal to percent, all I've got to do is times by 100. 43.75%. While we're at it, 45 times 100, 0.45 times 100 is 45. Also, while we're at it, let's get this 2.5 and divide it by 100 to take it back to a decimal. One movement takes us there, 2 takes us there. So it must be 0.025 as a decimal. 45% literally means 45 per century. But they've got 5s in it. How many 5s up top? 9 5s are 45, 20 5s are 100. There's no more common factors apart from 1, and 1 doesn't get us any smaller numbers. This one, I could think 2.5% again, but technically that's not a fraction, because that's not a whole number. I could times divided by 10. I could make it a 25 on 1,000. Then I could say there's 5 5s there, and there's 200 5s there. And then I could say there's, a single 5 there. Nah. And there's 40 5s in 200, so 1 on 40 is my answer. I could also have just thought, times the top by 2 and the bottom by 2 would make it 5 on 200. There's a little shortcut. But I'm still going to divide top and bottom by 5. There's 1 5 there, and there's 45s there. Either way, my simplest form, because it says fully simplified, is 1/40th. Okay, all the best. See ya.